Hello friends, now we'll think about the second portion. Last time we discussed about the basic point of electrical potential. Just revise, you can see plus Q charge at the origin point. Because of this plus Q charge electric field, inside the electric field we consider a 2 points R and P. Test charge is situated at point R and the work done required in moving this test charge from R to P. This is the formula of work done. Last time we derived work done required in moving this test charge from R to P. It is integration minus R to P Q E dot dr. Just remember. So WRP upon Q is equal to minus R to P E dot dr. You can see this is the most important formula last time we derived. What is the meaning of this point? It is called simply work done per unit positive charge. You know that very well because of last lecture. And this work done per unit positive charge, it is called simply electric potential, and electric potential is denoted by VRP is equal to minus R to P E dot dr. This is the formula last time we discussed, and from this entire discussion we can easily define the potential. So just concentration required now. This lecture is very important for the next coming lecture. This is the base one. Or this one is the, you can see that the basic one. So just concentration required. A very interesting point. First of all, we will start with the JEE NEET. These all points are very important. Number one, what do you mean by electric potential? So we have idea about it. Electric potential is nothing but it is equal to the work done per unit positive charge. It is called electric potential. So electric potential is denoted by V. V is equal to W by Q. This is the most IMP formula और ये फ्यूचर में बड़े पैमाने पे धूम मचाने वाला है. Be alert about it. V is equal to W by Q, most IMP formula, and from this equation we can easily obtain unit joule per coulomb. Another unit because of scientist Volta. Volt is another unit of electric potential. You know that very well, scientist Volta. So very interesting point. These are the two very important units, volt, joule per coulomb. And this is the equation, or this is the question already asked in examination. Joule per coulomb is equivalent to blank. It is equal to volt, or volt is equal to joule per coulomb. Don't forget this relationship, very important for 1 mark MCQ. Okay, next point. I would like to represent this equation now in terms of difference, potential difference. So in terms of potential difference, recently we have written this equation VRP is equal to integration of E dot dr minus from R to P. Just you know that very well. So this VRP, that means the potential difference between 2 points VP minus VR. What do you mean by VP minus VR? It is called potential difference between 2 points P and R. VP minus VR is equal to minus R to P E dot dr. Very important formula. Don't forget. This is called potential difference from today. Now this one is the very important point. PD. PD, that means potential difference between 2 points. PD between 2 points P and R. Most important. VP minus VR. So this can also be written like in this way, delta V. Potential difference can also be written like delta V. Delta V is equal to W by Q is equal to minus R to P E dot dr. So these are the most IMP formulae. ये formula भी बड़े पैमाने पे धूम मचाएगा. So most IMP in terms of potential difference. So you can also write like instead of delta V, Vp minus Vr W by Q is equal to minus R to P E dot dr. This is also very important. Keep in mind, these all are very important formula for MCQs, numericals, and we can say that some fundamental conceptual point for the further questions or further topics. So once again, what do you mean by electric potential? It is simply the work done per unit charge. V is equal to W by Q. From today, this equation required in your mind. You need joule per coulomb. Joule per coulomb is also equivalent to volt. Volt is equal to joule per coulomb, most time P. One more important question: what is the unit of electric potential? Joule per coulomb. But sometimes they ask the question, what is the unit of line integration of electric field? Then what's the answer? Obviously, line integration of electric field over the given path is simply potential. So what is the unit of potential? Joule per coulomb. So joule per coulomb or volt is the unit of line integration of electric field. Similarly, they ask the question about surface integration of electric field. Anybody? Surface integration of electric field. What is the unit of surface integration of electric field? Remember chapter number 1. Surface integration of electric field. That means electric flux. And what's the unit of electric flux? Newton meter square per coulomb or volt into meter. These are the very important points. So don't forget. Next point, potential difference. What do we mean by potential difference? We'll discuss, don't worry, but this is only formula point of view. We'll think about the next point, potential difference. So VRP, last time we derived VRP minus R to P dot dr. VRP is also called potential difference between 2 points VP and VR. So it is called PD between 2 points P and R. It is also written like in this equation delta V or VP minus VR is equal to W by Q minus R to P E dot dr. These are the very important formulae. Don't forget, this whole formulae, most IMP formulae for, we can say that MCQs. What type of MCQs? Just concentrate here. So this one is the very important point. So don't forget. Once again, revise at least 1 or 2 times. Try to remember this each and every formulae, because this one is the, we can say that the important portion of this chapter. How? We'll check it by considering one basic MCQ. So one MCQ from my side, and you have to try, okay, to solve it. We provide some time. You can see this one is the, we can say that particle, charged particle. I can write here charged particle. It is situated at point A. Let the potential at this point A is 100 volt. Potential here 100 volt. Now we would like to move this charged particle having mass 2 milligram and charge 2 microcoulomb. Whatever the charged particle here shown in this diagram, which is situated at point A, where potential 100 volt, what is the mass of it? 2 milligram. What is the charge of it? 2 microcoulomb. We would like to move this charged particle from point A to B. A to B. Let the potential at this point B is 0 volt. So one point is clear. At point A 100 volt potential, at point B 0 volt potential. So obviously point A at high potential, point B at low potential, and we would like to move this charged particle from A to B. Okay, so whenever if you move this charged particle from A to B, so what's the question? Calculate the change in kinetic energy of this charged particle. If you move this charged particle from A to B, then what is the, we can say the change in kinetic energy of this charged particle? Take 1 or 2 minutes, because this is, you can see the lecture, like live lecture, so you have to apply your concept yourself and then we'll solve it, don't worry. So take your time for 1 or 2 minutes. Okay friends, so now we try to solve it. Whatever the answer we can't, we can say that match your answer with the correct one, but try to check it. Your target to calculate the change in kinetic energy. Change in kinetic energy, that means delta K. You know that very well, this change in kinetic energy associated with work done, and work done is associated with potential or potential difference. So as per work energy theorem, you know that work done is equal to delta K, but you know that very well, work done, we have idea about the potential difference delta V is equal to work done per unit charge. It implies that work done is equal to delta V into, we can say that Q. Okay, so instead of work done, we can put here delta V into Q, while here delta K, that's your target. So delta K is equal to Q into delta V. Q already here 2 microcoulombs, so 2 into 10 raised to minus 6. Delta V, what do you mean by delta V? Delta V, that means the potential difference between A and B. That the potential at point A is VA, potential at point B is VB. So I can write here VA minus VB. Don't write VB minus VA because you are moving your charged particle from higher to lower potential. Keep in mind, anytime charged particle is moving from higher to low potential or higher to lower, then obviously potential difference positive. So 2 into 10 raised to minus 6. What is the potential at point A? Already 100 and 0. So change in kinetic energy, it is 2 into 10 raised to minus 6 multiplied by 100, 10 raised to 2. So it is 2 into 10 raised to minus 4 joule. That's your answer. And if you obtain this answer, then congratulations, definitely. So this is the very interesting point. You can see once again, we have applied this one of the very important formula. Change in potential difference is equal to work done by charge. So these are some basic questions. So you can see in this type of questions, some basic concepts are very useful. Now, what do you mean by potential difference and what is the importance of it? You would like to think about it now. So be alert about the next topic, potential difference. Keep in mind, electric potential or the absolute value of potential is not useful. For example, what is the basic definition of potential? Now, we'll think about some very important basic points. Electric potential. Just check it. Last time we derived this formula, VRP is equal to minus E dot dr R2P. VRP potential difference, it is VP minus VR minus R2P E dot dr. Any doubt? Up to here, any doubt? Okay, now you can see Vp minus Vr, that is the potential difference between 2 points P and R. But if you consider if point R is situated at infinite, then what happens? Then this equation can be written Vp minus Vr minus R to P, so infinite to P E dot dr. But at infinite point potential 0. So what is the potential at point R? 0. So what is the potential at point P? It is minus infinite to P E dot dr. This is your equation. You can see minus infinite to P dot dr. What is the meaning of this point? What is the meaning of this point? Vp is equal to minus infinite to P E dot dr. This is called the formula of potential. It is called electric potential at point P. And what's the definition now? At point P. You can easily define work done required, because potential, that means work done. Work done required in moving unit positive charge from infinite to given point P. What is this scenario? Just concentrate here. This is, you can see that plus Q charge. Because of this plus Q charge, electric field is produced, electric field outside or outward. This one is the point P, and unit positive charge is situated at infinite distance. And now we would like to move this unit positive charge from infinite to P. In the previous case, we moved this charge from R to P, but now R is situated at infinite point. You can see here R. So whatever the work done required in moving unit positive charge from infinite to point P, It is called the electric potential at point P. For example, I would like to define electric potential at point A. Then what's the formula? Then it is denoted by VA is equal to minus infinity to A E dot dr. Suppose I would like to define potential, electric potential at point B. Then what's the formula? Then VB is equal to potential at point B is equal to minus infinite to B E dot dr. Suppose I would like to define potential at point X. So minus infinite to X, 8 point Y, minus infinite to Y, 8 point P, minus infinite to P, you can see. So this is the general formula of potential at point P. So nobody can define, that means this is the absolute value of potential. It is not, we can say, that important for us. Why? Because suppose I would like to define potential at this point. Suppose there is a point and I would like to define potential at this point. That means I have to move charge from infinite to this point. But the biggest question or the most important question arises that who will go at the infinite distance? So infinite distance, that means you can see that not possible for us, and that's why generally charge is already, we can say that moving or charge is moved from one point to other. I can say that possible distance are, we can say, the given. Generally possible distance, that means like here. Suppose these are the 2 points R and P. Now R is not situated infinite, R is somewhere here. So we can easily move this charge from R to P. So we can easily define potential difference between these 2 points. So that's the reason absolute value of potential is not important for us, but the potential difference is very important for us, because for absolute value of potential we have to move charge from infinite to given point, and it is, you know that very well, not possible at all. So generally we always prefer potential difference. For example, if you consider the flow of current at your home, if you switch on, we can say that tube light or fan, then what happens? Current passing through wire. Why? Because charge will flow from high potential towards the low potential. So potential difference between switch and fan, switch and you can see that tube light. So potential difference very important. But suppose I would like to define potential at tube light. That means I have to move charge from infinite to tube light. Once again the question arises that who will go at infinite and how can you move the charge from infinite to tube light? So it is not possible. So generally absolute value potential is not useful, potential difference very IMP. So that's why now we think about potential difference. So you can see that to discuss or to get information about potential difference, now we start the story. Just concentration required. Already we have discussed, but now in detail form. Electric potential at point A minus infinite to A dot dr. Electric potential at point B minus infinite to point E dot dr. Now I would like to obtain potential difference between A and B. In short, VA minus VB. So by taking difference of this VA minus infinity to A E dot dr. Here minus, this one is the minus VB, so here plus minus infinity to B E dot dr. Ready? Now I would like to remove this minus sign. You know that integration, if you remove minus, then obviously limit get interchanged. Upper limit becomes lower, lower become upper. E dot dr plus infinite to B E dot dr. This is your VA minus VB. Now B group student, be careful, because now we have to apply the concept of integration. What is the, we can say, concept of integration? This is, you can see that finite integration. There are two types of integration, infinite, finite. But finite integration, then there is, we can say that one formula. You can see A to C, or I can write A to B plus B to C, it gives A to C. This is the formula. A group student will learn in, we can say, the future in mathematics. So A to B, here A to infinite plus B to C, here infinite to B. You can see that here B common, here infinite common. So what is the final answer? VA minus VB is equal to A to B. Direct you can see that A to C, like that's the result. So A to B E dot dr. But once again I would like to interchange the limit. Then what's the answer? Here plus. So B to A, it becomes negative E dot dr. And this is the most IMP formula. You can see Thun formula. This is called potential difference between A and B. There are three meanings. Now be alert. Three meanings of this mathematical form. Number one, this is called potential difference between A and B. Number two, very IMP. This is called potential. This formula indicating potential at point B with respect to potential at point A with respect to point B. Don't forget, potential at point A with respect to B. How can you write this equation? Keep in mind here with respect to, very important. Here with respect to point B, with respect to whatever the point, it becomes, you can see the lower limit. With respect to B, so B in the form of lower limit. With respect to A, then A. With respect to C, then C. Here with respect to B, so B lower limit. So it is called potential at point A with respect to point B. Once again, there are three meanings. Number one, potential difference between A and B. Number two, potential at point A with respect to B. And number three, very IMP, this equation also gives idea about the work done required in moving unit positive charge from point A to B. Most IMP, or you can also write B to A, don't worry. So work done required in moving unit positive charge from B to A. Most IMP three meanings once again. First of all, potential difference between A and B. Second number, very IMP for numerical or MCQ, especially JEE need. Second number, potential at point A with respect to B. With respect to B, so lower limit B. Then work done required in moving unit positive charge from point B to A. So very IMP formula. This is called potential difference. You can see, and this is very interesting point we have derived. Now we'll apply this concept. But before moving this concept, first of all we will think about some basic discussion. For example, here VA minus VB. I would like to obtain potential at point X with respect to Y. Then how can you write? Potential at point X, so Vx minus with respect to Y, Vy. What's the formula here? Here with respect to Y, so obviously minus Y to X E dot dr. Suppose I would like to find potential at point P with respect to, suppose, any origin point O. Then how can you write? Vp minus Vo with respect to O, so O to P E dot dr. These are the some practice points. Don't forget, potential at any point with respect to other, then it can be written like in this way. So these are the very important points we have discussed, friends. Second segment we have completed. Just analyze this second segment, then we'll move towards the third one. Third one is very IMP because now think about application of this whole formula, and we would like to solve some very important JEE NEET questions. So prepare these whole points. If you have any doubt, then you can ask me on call. We will discuss. Okay, but don't waste your time. Just we can say that spend some time, particularly for fundamental and some conceptual study. Theoretical pamphlet also will be given or will be sent, we can say that via website. Okay, thanks. We'll meet the next lecture.